It turns out that Ceres, the first and largest asteroid discovered in the main asteroid belt, surprisingly has been geologically active within the past billion years. NASA's Dawn spacecraft arrived at dwarf planet Ceres in March 2015.
We were expecting an inert, rocky body.
We expected Ceres to be a cold rock.
One intriguing feature Dawn discovered on the surface of Ceres is an enormous lone mountain the team named Ahuna Mons.
We are looking in detail about the shape of the mountain.
It was very tall and had steep slopes, and that reminded us of certain places in the solar system, including Earth and Mars, that had domes that were formed by volcanic activity.
We found that Ahuna Mons' shape is very similar to that of a volcanic dome.
Along with the shape of the dome, the facts are that there is no evidence of another formation mechanism such as an impact crater, and the surface features on the summit and sides of the mountain look incredibly similar to known volcanic domes. This all provides substantial evidence that Ahuna Mons is in fact of volcanic origin. Volcanoes on Earth are fueled by magma composed of molten rock, but Ceres is far too cold to melt silicate rock in its interior.
We then concluded that the magma had to be composed of mostly very salty water, and when exposed to the surface, they would freeze and form this steep-sided dome.
A volcano made of water or other ices instead of rock is called a cryovolcano. Scientists have detected evidence of cryovolcanic activity before. Plumes from Saturn's moon Enceladus and Neptune's moon Triton, and volcanic-looking mountain ranges on Saturn's moon Titan. The salty, muddy mountain Ahuna Mons is yet another new form of cryovolcanic activity discovered.
There's no other place in the solar system that has a structure that matches that of Ahuna Mons, and it has to be formed by cryovolcanic activity.
Moons around gas giants can heat up from the frictions of their interacting orbits. But the isolated dwarf planet Ceres is so small and cold that we wouldn't have thought it could have liquid water in its recent past. Evidence suggests, however, that Ahuna Mons is a relatively young feature.
First of all, the surface is very bright, and as the surface gets darkened with time, its brightness tells us it's a young feature. And second, we see very crisp morphologies, very sharp features. And this also tells us it's a young, as the features get muted and smooth with time. And third, we have been looking at the crater density, and we see very low density of craters. And this tells us that Ahuna Mons was formed the last billion years of Ceres history. Ahuna Mons is the evidence that Ceres was active in the recent past and might be still active today.
That tells us that there has to be something beneath the surface of Ceres, near Ahuna Mons, that heated the material to the melting point and made it push through the cracks on the surface.
The source of this heat is still an intriguing mystery that planetary scientists are anxious to solve.